Hey guys, this is Coach Lowe, and we are going to talk about 4.2, parallel lines and transversals, and this is contextual geometry, so let's get started. All right, first of all, we know what parallel lines are, two lines that are never going to cross. Here is notation for that. If you have two lines graphed like this on a in a plane, they will note parallel lines with arrowheads. So those two marks mean parallel. Let's say that this is line AB and line CD. So line AB, we would say, is parallel to line CD. So this symbol in the middle means parallel. So just drawing two lines that look like they're parallel to each other, small, actually segments in between those means parallel. All right, special things happen when you have parallel lines cut by a transversal, but let's talk about transversal. Transversal is a line that intersects two or more lines. A line that intersects two or more lines is a transversal. A line that intersects two or more lines is a transversal. So this would be an example. I just put line T. Line T in this case is a transversal. It intersects A and B not at the same point. So it's intersecting line AB here and line CD here. So a line that intersects two or more lines at different points is called a transversal. All right, so let me get to a new page and let's look at non-parallel lines first, and then we'll look at a couple of parallel lines. So here are a couple of lines. We'll call this line L and line M, and let me get a transversal going here. So there's my transversal cutting through. Anytime this happens, when I have at least two lines cut by a transversal, four sets of angles are formed. Or excuse me, two sets of four are formed. So there's 1, 2, 3, 4 angles here, and then 5, 6, 7, 8. So there's the other set of four angles here. It also separates into some sections, like inside the parallel, or excuse me, inside the lines, the two lines here. So all of those angles, 4, 3, 5, 6 are on the interior or inside of L and M, and 1, 2, 8, and 7 are on the exterior of L and M. All right, so we have interior angles. So on the interior, we have angles 4, 3, 5, and 7. And on the exterior, we have angles 1, 2, 8, and 7. Sorry, I said 7 here and I totally meant 6. Hopefully you caught that. So exterior, on the outside, I'll shade that a different color. How about blue? Get some prior colors going here. Well, it's kind of light blue, but that's okay. Blue and some yellow there. So exterior and interior. All right, now we're going to talk about relationship with the transversal. All right, so there are some angles here, this angle and this angle. They are called alternate interior angles. So they're inside the lines and they jump across, they alternate sides of the transversal. 4 is on the left side, 6 is on the right side. So alternate interior angles would be angles 4 and 6, and then also angles 3 and 5. Those two angles also alternate the transversal. All right, so let's talk about alternate exterior. You could probably pick those out already. Alternate exterior. So they are going to be exterior on the exterior, so in the blue, and they will alternate the transversal. So 1, I'll take that on the exterior, and then I have to jump across the transversal and get on the outside again. So 1 and 7, and 2 and 8. All right. Consecutive or same side interior angles. So same side of the transversal, so consecutive interior, and I like to call it same side. So that helps me know I'm on the same side of the transversal. So same side interior. So I'm on the in the yellow on the inside. So angle 4 and angle 5, and then angles 3 and 6. All right, same side interior. All right, so we have alternate interior, alternate exterior, same side interior. All right, so this is theorem 4.1, and this is theorem 4.2, and this is theorem 4.3. All right, so cool things happen when our lines are parallel to each other, and I will talk about that in the next video. This is Coach Lowe, and I'm out.